This video, we're going to talk about the standard template library. There'll be two videos on this. This is the first one. So I've got a picture of the book up here because most of what we're going to be covering is straight from the book. There's nothing all that complicated. Okay. So the first thing to know about the standard template library, it was in some ways a reaction to languages like Java, who had a bunch of stuff built in, and C++ didn't. You had to build it yourself, as we've been doing all semester. So they came up with the idea of a standard template library, which would add in some of the basic data structures and some different things that we can do, okay, based on that. Okay. So there are three main components of the standard template library. First are going to be containers, which we'll talk about some of the container types. Also iterators. Iterators just allow you to go through one by one on data structure. And there are algorithms, which let us do things like sort and copy and things like that. Okay. So the containers themselves, a bit bigger here. The containers themselves come in the following varieties. Okay. We have sequence containers. They're also called sequential containers. Those are things that have a specific position. Okay. There's also associative containers. Those are going to be kind of like the dictionaries in Python. And then there are container adapters. Okay. So the sequence containers then are made up of the three big types here. The first is a vector. Okay. So a vector is going to be pretty much a dynamic array, stores things like an array. Then we have a DQ, and then we have a list. Okay. So with the vector, again, we can include the vector library up at the top of the program to give us access to it. And then we can declare a vector. Again, standard template library means that they're templated functions, which means we send it the type. So this would be a vector of ints. Okay. So you don't declare a size. It's going to basically, you can make it as big as you want, although there are some limits based on how much memory you can allocate. Okay. So here are different ways that we can declare and initialize our vector container. Okay. And then we have the following functions to access. We have either an @ with the index, which is very Python-like, or we can put the brackets to get there. There's also a front or back that refers to the first or returns the first or the last element in the vector. Okay. We can loop through these, as you would imagine, just like that. Okay, pretty straightforward. Some other functions about the size of the vector. The capacity will return how many number of elements you can insert into the container without having to relocate it in memory. Now, we said it's a dynamic array, and it is dynamic, but it still allocates so much memory, and it can grow until it runs into something else. So at some point, it may have to move it to a different spot in memory. So that gives you that number. There's also a Boolean function on empty, returns true if it's empty, false if not. Size returns how many elements are currently in the vector. And then max size returns the maximum number of elements that can be inserted into the container. Okay. Other functions we have here, we have clear, which will delete all of the elements from the container. We can erase at a certain position or erase a range of positions. Okay. We can insert at some position in the array. Okay. We can insert some number of copies of the element at the certain position in the array. Okay. We can also insert with a beginning and an end range. Okay. The pushback will add it at the end of the array, of the vector array. The pop back will delete the last element. Okay. You can resize along the way if you want. Okay. Here's an example. You're declaring an integer list here, and you're pushing a couple of things on there. Okay. And then this is what it's going to look like. Okay. The iterators, then we can declare an iterator to a vector container in this way. Okay. So it's the iterator that we're calling it this. Okay. And once we have the iterator, we can do a ++ to move it to the next item. Then we can do a star, which is like with a pointer, it's going to dereference that and give you what's at that current position. Okay. So here's an example of declaring a vector, okay? And then here is an iterator, okay? We haven't connected these two together yet. We can connect it with the begin, which points to the beginning of the list, or the end points to the end of the list, okay? That's how you can get the iterator set up, okay? So this is, again, going through that stuff, setting the vector to the vector begin, moving it one forward, inserting, things like that, okay? Here's a whole program on using vectors. You can get a better example of how that works, okay? So vectors are pretty straightforward. And we also have some functions that are common to all containers, no matter which ones you have. Okay, so every one of the containers has a default constructor, has a constructor that takes parameters, has a copy constructor, it has a destructor. Okay, those are built in, you don't have to worry about them. There's also an empty and a size function, okay? There's a max size, there's a swap, we can swap two elements. There's beginning and end for the iterator, that's return an iterator, okay? There's a reverse begin, which is pointer to the last element. All these things, okay? So then the sequence containers, which are the vector, the DQ, and the list, have some other things that you can do that are based on positions, okay? So those are all there, okay? And then our first algorithm we're talking about is that there's a copy algorithm, okay? And the copy algorithm allows us to copy over things directly, okay? Let's see if it's giving us somewhere an example of that. Yeah. So here we're going to copy from the vector list at the reverse beginning +2 to the vector list plus the reverse end, and then the vector list beginning there. Okay, so our begin function's reverse begin. It's a pointer to the last element. Okay, so the +2 is going to return the third to last element because it moves in reverse. Okay, so that's explaining what that works. Okay. Okay, then it talks about the OStream iterator and the function copy. Read through that, gives an example here of how that works with the copy. Okay. More examples with vectors here. Okay. And then, yeah, it talks about, oh, it's still a vector. Okay. More examples down here. Okay, and you can declare your vector when you declare it, or you can initialize it when you declare it if you want. That's certainly a possibility. Okay, and let's see. Yeah, the next one's the DQ. Okay, it's a double-ended queue. So we've done queues before. The queues usually are at a first in, first out. So this one just has pointers at both ends. Okay. Also, the elements can be inserted in the middle if you want, because again, it is a sequence. Okay, so inserting the beginning and the end is fast. If you insert in the middle, it's going to take you longer. Okay. So again, we have the different ways to declare a DQ or double-ended queue. It has the basic functions here: the push front, pop front, the at, the front, and the back. Okay. And there's an example of the DQs. Okay. Then we have the list. Okay. So lost it all. Let me find it again. Oh, the wrong way. Yeah. So the last of the sequence containers is the list. Okay. And the list are doubly linked lists. Okay. So every element points to its predecessor and its successor. Okay. Except for the first and last elements. Okay. So remember, linked lists are not random. You can't get in the middle, therefore you have to start at the beginning and go all the way there. Okay. So instead of all the pain that we did in programming our linked list, we could have just included lists and we would have been there. So such is life. Okay. So again, we have different ways to declare our list here. Okay, and then our standard operations on the list, we can push front, pop front. We have our front and our back. We have a remove. okay, and a remove if based on some operation, a unique, okay, which will remove list values that have the same, list elements have the same value, okay. Also, list allows us to do things such as a splice based on combining different lists. We can do a sort, okay. We can sort based on some operation other than the normal way to do things, okay. We can do a merge here as well. It will merge list 1 and list 2 together, okay. Now note, after this operation, list 2 is empty, so it's going to be destructive to that, which in dealing with queues and stacks is pretty normal, okay. We can also do a reverse on that. So here's an example of a program with a list that you can read through to get an idea of how that works, okay. And I think that's probably a good point to stop this time, okay. So for the video that will come out on Monday, we'll start with iterators, okay.